Good morning. So happy to have you here again, traveling from all over the world, joining us again for another intense, exciting, and successful prpl Summit, this time prpl Summit Americas. With your contribution, happy to have Joe with me today.
Hey everyone, thank you so much for having me.
Round of applause for Joe.
And Livia.
He was very kind to share the stage with me for this show, and so I'm very excited to have him here. And contributing not just because I'm a low-frequency voice person, but all the energy vibe that we need, and lots of surprises that we'll share with you during the day. Because we're already 5 minutes late, we're going to start already with Peter.
Peter. Yep, prpl Foundation, project manager, prplOS. Thank you.
Thank you. Thanks, everybody. All right, so let's get started for today. I hope we have everything on the screens. So it's my pleasure and an honor to do the opening session to the prpl workshops today. I want to give you a quick walkthrough how to build, flash, and configure prplOS on a device. I've prepared some slides and a few small things to demonstrate. Not getting too technical, so don't be worried about that. Okay, before we get into the actual process, I want to give you a quick overview of prplOS. I see many familiar faces, so you probably already know about that, but we have some newbies here, so that's for you. So prplOS uses the OpenWRT build system and many of the OpenWRT components, which is a good thing because we have many engineers out there who are already familiar with OpenWRT, so they have a very steep learning curve here. prplOS adds some carrier-grade features that are required by operators to the foundation of OpenWRT. So for instance, a complete security architecture for deployments and operations, lifecycle management, remote management using TR069 and TR369, easy mesh, we call it prpl mesh, and a lot of other components. There's a strong requirement from the prpl Foundation that all those components conform with the high-level API, which is based on the TR181 data model from the Broadband Forum and the low-level API. So technically Linux APIs, and where there are no APIs, the prpl Foundation is making definitions for those. Here's a quick diagram to demonstrate how this looks like, just a visualization. So you can clearly see the low-level API, the high-level API. And the high-level API, this is really what the operators care about, to have a standardized data model which is reflecting the device's configuration and status in a way that can be centralized, can put into a centralized management system. Okay, that was unexpected. Okay, all right. Okay, let me get back. Okay, so which brings us to the hardware. If you want to run prplOS, of course, you need a hardware platform for that. So in prpl, we decided we have to focus on operator class hardware. We call it carrier grade. And we need support. So we said, OK, we have a few platforms we call accelerated platforms, which are on a so-called fast path. And those platforms are carrier-grade hardware, so they come with all the interfaces carrier box needs in the field. And we get direct support from the chipset vendors and the device makers to do the software adjustments needed to run prplOS. And those platforms also get integrated with the prplOS continuous integration. But of course, we have lots of more supported platforms. So technically, every device that can run OpenWRT can run prplOS because of its foundation. You need sufficient hardware resources. I mean, we are running a complete TR181 stack on the device, a lot of services, so we need some CPU power, flash, RAM, and etc. Also to note, from time to time when we release new versions of prplOS, we are changing the accelerated platforms because we want to bring to the companies consuming prplOS the latest and greatest hardware features, and with new standards evolving, we are switching that. But that's not a problem because we keep the formerly accelerated platforms in the CI for a while to provide some continuation. So this is those are gonna phase out over the time, but in the meantime, everybody should have the latest hardware. This is specifically important right now because currently we are on prpl 3.0, which is using OpenWRT 22.3 as a base with a minimum kernel requirement of 5.4. And here the FastPass platforms are MaxLinear's Open Services Platform version 2 and the Haze platform based on Qualcomm. Both platforms use Wi-Fi 6. And you know, Wi-Fi 7 is already there, and we have to move. So with prpl 3.1, which we hopefully can release in June, we are switching to OpenWRT 23.05 as a base version. And then we will have Open Services Platform version 2 coming with Wi-Fi 7, and the Freedom platform from Qualcomm also with Wi-Fi 7. Also, those two platforms then will come with support for 5G modems. The modem support is on the roadmap for 2024 for prplOS. This is also an important feature, I think. And as you can see, the formerly accelerated platforms will still be in CI and supported. Yeah. Yeah, which, thank you, Frederick. You can see here on stage. So we have here Open Services Platform version 1, and besides it, the prpl Haze. Of course, at the customer's place, the boxes won't look like this, hopefully. Okay, so getting now to the more practical parts. To build and run prplOS, of course, you need a few preparations. You need a Linux operating system, including the Linux developer tools to build. You need Git, you need Python. You need a serial connection to the device you want to work with. And depending on the hardware platform, you also need some agreements with the chipset vendor. This is because some components, for instance, Wi-Fi drivers, may not be available as open source from the chipset maker. In this case, you need an NDA, and you need access to the chipset maker's repository. The requirement from the prpl Foundation is that those sources are organized in feeds. This is the common way to deliver components to OpenWRT. So once you have the NDA and you have your account, you get a feed, you get access to the feed, and then you can build prplOS. All right, so building prplOS, it's 3 simple steps. The first step is you check out the source code. The second one is you configure the build, and then you build. So let me just show you the first 2 steps. I mean, it's not rocket science, thank God. And the mouse is not working, which is not so good, but we'll manage it. All right. So we have here a Linux system, and everything is in the wiki, by the way. So you can see here already the instructions needed to check out the, let me see how this works. Mouse is not working. Did you turn it off? All right. Something's not working. Martin, could you have a look? The mouse is not working. Ah, now it's working. Okay. Okay, thank you. You see, the most simple things usually don't work. All right. Let's get back to our screen here. Okay. Everybody who was already working with Git, you already know about that. So, but the configuration, this is something important. Because in OpenWT, you have the menu config tool, which is very powerful. But you really need to know which packages you have to activate, dependencies, etc. So what we did for prpl,OS, we have a simple configuration script. You can see the path here. It's gen config. And as optional parameters to the configuration script, you provide some profiles. So we have profiles for the platforms. We have, of course, a prpl,OS profile. We have a security profile, etc. So you just select those profiles, and then this script takes care for everything else. And it also automatically runs the configuration building of OpenWT, so it pulls in all additional packages it needs to build. All right, perfect timing. So we're ready to go. Okay, we need this done. Okay. Okay. And as you can see now, the system is again pulling new sources in, yeah, to get everything working. Once this is completed, you just type make, and then you have to wait. And you have to wait some time, because what's happening is that first, the whole tool chain is built from source. And this process really, depending on the CPU power, can take 30 minutes, 60 minutes. It's some wait time, but good news, you only have to wait once. After you once built the tool chain, most of the main packages, if you make smaller changes, a build takes maybe 5 to 10 minutes. That's quite fast. And after doing the build, which I'm not going to demonstrate here, that's for sure, you find the firmware files in the usual place, bin targets, and then architecture, etc. And you're good to go. Okay, now while this configuration process is running, let's not get bothered too much with it. Hopefully it's going to done soon. Let's get to the point of getting the firmware onto the box. So flashing prpl,OS is done like with OpenWT using the device's bootloader. Unfortunately, for the time being, the way it's done, the bootloader differs on the device. We are working on standardizing this, and Wouter, tell me if I'm wrong here. Yeah. This is also one of the activities he's going to talk about later. But for the time being, processes are a little bit different. But usually what happens is you access the bootloader, and then you have to do some settings, pull in the firmware via an Ethernet connection, and then you're good to go. All right, let's get on the box. Never worked with a Belgian keyboard. Here. There we go. All right. Okay, I'm currently rebooting the device to get into the bootloader. The bootloader usually automatically starts the system, but you can interrupt the process. This is going to take a few seconds. So you can already see all the commands we need to run in the upper window. So we now have a bootloader here. Most vendors use already U-boot for that. And here you can check with print and the configuration. So what's important before you start the flashing process, to check the IP address settings and also the ports on the device. Yeah? So the IP configuration should match the configuration of the PC you are using to pull the firmware from via TFTP. And also you have to use the right port. So for instance, for the Haze and the Freedom platform, when you want to flash, you have to use the WAN port on the device, the red one, because the other ports are not functional in the bootloader. This was causing some friction with the developers, because they were like saying, hey, the Ethernet is not working. I have to use the right port for that. But it's now it's all documented, so we don't have this problem anymore. Okay, just let's go through the steps. So the first step actually is pulling in the firmware image to the box. So this is technically the actual preparation for the flashing. Let's get the next one. You see the image is quite big. That's why the hardware requirements for the devices I mentioned earlier. Right. Okay, now the firmware is flashed, and we just need to reboot the device. Yeah, and if everything goes well, you will see this. And here we go, voila. Now we have flashed prpl on the box. You see it's not rocket science. And the whole process is documented in the wiki. So you have the build instruction, flash and stuff, instructions for each accelerated device here for reference. Okay, let's come to the part now that's probably most important, configuring prpl OS. So, as I initially said, prpl OS uses the TR-181 data model for its high-level API. And this data model is the single source of truth. So all configurations of the box are being done via this data model. This is especially important since some developers who are familiar with OpenWRT, they tend to configure some lower level configuration files, but those are going to be overwritten. Yeah? Because we decided this is the way to go. This is the approach prpl is taking. So please keep that in mind. prpl uses a microservices architecture to implement the high-level API, and all those microservices are communicating with each other using the OpenWRT U bus, which is an internal system bus to allow process intercommunication. So technically, you could send your TR-181 payload for the data model using the ubus command with a JSON payload then, which is okay, but not that handy. So we introduced a simple command line tool, which is called ubus CLI. And this command line tool allows you to parse the data model, to modify the data model, etc. And it's quite simple. You just call ubus CLI. You get a prompt. And from here, you really can query the data model. Just an example, you want to query device IP. Oh, sorry, I need the dot. Oh, okay. So where's the screen for that? Because technically, could somebody please check where's the screen from this laptop? This is unfortunate. Ah, here we go. Okay, thank you. Yeah. So for instance, I want to see which interfaces I have. Then I just type, yeah. So, okay, this is a lot of information, of course, but this is how you can query the data model. Yeah? You can also check, for instance, you want to know the LAN interface's IP address, which is a common use case. Yeah? You can also use placeholders here. As you can see, it has auto-completion, and it gives you some hints. So you can see, okay, I have a loopback device, I have a LAN alias, I have a LCM alias. So I just say, okay, I need my LAN and then we need our IPv4 address. I should actually be very familiar with that. Okay, here we go. Okay, so now you can see we have here our IPv4 address. Okay, nothing works at the end of it. All right. Okay, so this is conforming with the TR-181 data model. If you want to change the parameter, you just set it. Changes are applied instantly to every part of it and also to the box. I don't change the IP address now because I don't want to mess up the other demos. And all of this is also very extensively documented in the wiki. Okay, yeah, this was just what I was talking about. Yeah, you have the interface aliases, for instance, to help you a little bit. And with that, I'm just in time, so I was catching up a little bit, Olivia. Thank you so much.